Alright, hello all. Hello world. This is day 89 of studying compilers every day until I land a compiler role. Yeah, today's stream I fear might get cut short because I'm supposed to... Holy blurry. Yeah, I'm supposed to be working on an OS lab right now. But instead I am contemplating my poor life choices and trying to figure out how to how to do compiler things. So it's gonna be a good time. Let me unblur my camera real quick. Okay, cool, that works. So yeah, last time we got through implementing most of the stuff for tree merging, but the two things we missed are first actually doing the merge, because low-key that's kind of difficult. And second, and more importantly, troublesomely, you get what I mean. More importantly, I realized we don't have a good way to actually compare trees yet. So I'd want like a tree compare function. So I think I should at least get that done at a minimum. And then if I end up having time, or if I decide against working on the OS lab that I really should be working on instead, I might start doing the merge stuff. Actually merge trees. The other thing I was thinking about is maybe a string representation or like a serialization of the tree. Something I can print out so I can kind of make debugging a little bit easier. But we'll see what I end up doing. So yeah. Last time my PC also decided to brick after I tried installing CUDA for machine learning, so we'll just reset this. Okay, cool. So let's get this started. Yeah, so this merge stuff is here. The other thing I want to check is we want some sort of tree comparison, as I mentioned earlier. So I think I'll do that here. Maybe I could even just throw that at the top of the thing, I think. Or just at the top of like merge trees. Or like, as in, like in here in the loop. Or, I guess inside try merge, right? It's not assembly. Okay, so this we want to try merge. Okay. So this should be here, I think, right? We should compare tree 1 and tree 2, I think. And then, yeah, we can't just like directly compare, because that wouldn't work. Yeah, we should probably make like a tree compare thing, because we're gonna need to do that a lot anyway. Yeah, because this isn't the only place. So I think it'd be helpful to throw in here. Maybe I could like overload the equals operator, but that seems a little overkill. Okay. So let's throw in like, I don't know. Let's do like bool equals, and then we can take like node star other. Oh yeah, we can do node star. Yeah, we can just straight implement this, I think. I think that's how C++ works. We'll find out very quickly if it's not. Or maybe we could do like register node? I don't know. I guess the only possible values for children are register nodes and registers and immediates, right? I think that's what we have, at least. Let's check how we gen trees again. So let's look up insert. There. Okay. So this is assembly, so that doesn't matter. This assembly. This one actually matters. Left and right are resolve value, so that is either a have that somewhere above actually. That's either a, where did it go? Oh, here it is. It's either an immediate or a register. Okay. Yeah. So then, that's fine. That's assembly. This has no children. This has a child, which is a putter, which is a resolve value. Source leaf and putter leaf are both resolve value. Okay. And then all of these are either assembly nodes or they are a register, it looks like. So that's reg, that's reg, that's reg. Oh, that's a store. Wait, that's different. But we aren't really, I don't think we can really merge that store into anything, so that's fine. And then everything else is assembly. Okay. So we kind of just only want to check if it's a register because we aren't really merging immediates into each other. Passing on to give you support, thank you, appreciate it. Okay, so I think, we don't even need this in here actually. Like that'd be the clean way to do it, but we only really care about this for merging. So we could just register this under here even. We can kind of just compare values. Or we could make this like a static function or something. Okay, let's make like a, I'm just gonna throw it into merge trees for now. I think this might be a bad idea, but I guess it doesn't hurt. We'll just call it like, I don't know, we'll call it like try merge, should merge, should try merge. Yeah, should try merge, that sounds pretty reasonable. So we have like bool, should try merge. Then we can take node star. I guess like same register? I don't know. I can do this, and then I guess we want to dynamic cast both. Oh, this is really stupid. I guess we could just static cast, right? I guess we're downcasting, so. Oh yeah, we should dynamic cast. Whoops. Yeah, okay. So we should just dynamic cast, unfortunately. Alright, so we can do T1 reg. We can dynamic cast to register node. Do you have a, I don't remember if we made a virtual register node. Looks like we didn't. That's good. Okay, so we have name. And do we have like a? Oh wait, no, it's not an immediate. Yeah, I see. Okay, yeah, this makes sense then. Okay, so we can do that. And then we give it T1. Oh, this needs to be a star. Whoops. So if not, T1 reg, continue. What's wrong here? Oh. Returned false. can do this with T2 as well. This should also be T2. And then return. One reg. Oh wait, did I actually add the equals? Oh, I did. Okay, let's not do that actually. Okay, so we can do this and then we want like get name, I think. We'll need this anyway, so I guess it's probably fair. Yeah, let's do that. Or actually, this kind of sucks. Let's just... Okay, we're gonna do... We'll just throw an equals in here, and then if we ever need to compare other nodes, I think we can resolve that at that point. Or we can do like same reg. Yeah, let's do that. Or wait. Yeah, we can do that. So do same reg as T2 reg. Arrow, whoops. Okay. So we can do that. Now let's implement it. I don't think that needs to exist in the header, so that's fine. Okay. Maybe it does. It probably doesn't need to. Oh, I'm looking in the wrong file again. I might be lost. Okay, so same reg. Yeah, so this goes here. So we can do that, return. Name is the same as other name. Arrow. Okay. Nice. So that works. I think. I can't test it yet. Actually, I can. I definitely can test it. We don't call this. I can't test it. Okay, let's do this. So we can wrap it like this, I think. Okay, so we can do this. Let's get rid of that real quick. So I want to do this. So if it's not same reg, we want, let's throw this in here actually. T1 and T2. Yeah, then we continue. Oh, we need to, this is star, this is shared footer. Okay, there we go. Yeah, so this we needed to compare to begin with, I think. Or wait, no. So this is a leaf, so this shouldn't be the same as T1. I would be very surprised if this was, so this is wrong. So then, so we want to compare this, and this is how we check if this is good. What is T2 uses back? That's the ref. I see. Wait, do we ever fill up T2 uses? Oh wait, no, we do. Wait, we do? Oh, we do. Oh wait, this should work then. Yeah, okay. We should do that, and then this is fine. This should be a straight compare, I think. And then the only other instance we care about, I think, is if that is the same ridges. Yeah, okay. This makes sense. Okay, so if there's another thing in it, we need to make sure. Okay, so we want same reg. We want to take this, and then we want to take this. All right, so we want this, and then yeah, we can. Actually, no. Let's, so we can do this. Let's just separate this out of the condition. Let's throw this down here. Okay, so then next back equals. So we want to check this. So if it's greater than 1. Oh wait, no, we pop back. Oh wait, this is invalid actually. We can't pop back yet. Yeah, we can't pop back. That wouldn't be safe. Okay, so we want to do that. We only pop back once we actually commit, I think. So this should be, we shouldn't even pop back actually. So we want next back real quick. So this is, we want to steal this. So that, and then why are we comparing against? Oh yeah, next you should be that. Wait, this one we don't need to compare because this should be just like the same place, the same instruction at least. Yeah, okay. So then, yeah, so then we can just like, wait, so this we should actually just stick in the condition. That's really funny. So let's just paste this back in here. If that equals, alright, so back, we want to compare the back to, is back an iter? Oh, that's a ref, okay. So we want to go back one more. Yeah, okay. Well, this is a little bit cleaner now. Okay, so these are the skip conditions. So these should be correct. Inside of here is where it gets really annoying though, because we can't directly compare. Otherwise, we already would have a merge tree, so that wouldn't make sense. Okay. Decided to try something new and apply to embedded Rust. Ooh, fun stuff. Yeah, you got it. Good luck. I believe in you. Okay. So then this indent is really funny actually. We've got nested lambdas. This shit is crazy. I'm not really sure why I did it like this actually. Actually, no. I know why I did it like this, but it really sucks that I did it like this. Okay. Maybe I should have just defined a macro or something. I don't know. Okay, so then the compare in here actually matters. So this is a shared putter, this is a shared putter. Maybe we should just take shared pointers in here. Or I guess it doesn't really matter. Yeah, these should be reges. Yeah, so we can do this. Same reg that, and then yeah. I quite don't like this actually. That seems very verbose. Yeah, let's just make it take let's make it take shared putters. Yeah, let's make it take a shared putter ref. Cool. And then we just put the git in here, which, I mean, it's fine, I guess. I feel like this makes no performance difference. I could just be completely wrong, though. I imagine there's like some cache awareness thing that I'm like forgetting about. But this works now, so that's good. Just from a readability perspective, I think this is fine. Okay, so we have that same reg. Yeah, this makes sense. If both are memory instruction, then yeah, so if both are true, then it may be aliases memory. So then we should just skip. Okay, well that was actually a lot less painful than I thought it would be. Although, I think once I start running this, I will find out very quickly that it is more painful. Okay, we should probably figure out a way to print these. Yeah, that would be smart. I should do that. Although I don't think we really care too much about pretty printing here, so we can kind of just like nest them in like a very like theory looking way, which is nice. Okay, so the other thing I want to think about is merge. How the hell do we merge? Yeah, that doesn't seem like it'll be fun. Oh wait, no, this doesn't work. Wait. Right? Does this work? Because we push on the leaves. We don't push on the instructions. So for each instruction, we get its leaves. Wait, what am I doing? Wait, this doesn't make sense. Huh. Okay, well. Right, because so T2 is the leaf. Is like literally the leaf. Wait, what? Oh, we need to fix this compare, I think. That's what we need to fix. Okay, yeah, then this should work, to be honest. Okay. So this should be This is a shared putter. And then T2 is also a shared putter. Okay. So we want same reg. Yeah, so we want to give this these two. Okay. I think that's correct now. Let's just look up all of the equals equals. Oh, like Son Goku. No, not really. You're free to think that. I'm not gonna stop you, but I don't really see it, I can't lie. Yeah, I'm not very anime versed, unfortunately. Which is really surprising given the way I look, but so it goes. Okay, so now I want to figure out merging. My camera is just permanently blurred, I guess. That's fine. Yeah, okay. So I guess I have time to do the merge. It shouldn't be that bad. Okay, how do we merge trees? So we want to. Oh wait, this is really annoying actually. I guess we could just literally update the shared pointer. Yeah, let me fix my camera again. Camera moment. Okay, so my idea is maybe we could just update the inside pointer of the shared pointer with like a or swap maybe? Yeah, we could just swap, I think. We could swap with the other we could swap with the, I guess, like, we could swap the leaf with, like, the actual tree, and that would probably solve our issues, and then we just have to update the skip list. Are the trees sorted? Yes, insofar as, like, they're in instruction order, but they're not, like, there's not, like, any, like, binary search sort of way to go about it, I think. Yeah, maybe the way I'm doing this is a little bit troll, actually, now that I think about it. Where are all of the slow... Yeah, I guess there's not really a good way to do this because I do just have to compare them. There's not really a good way to sort these, so I'd have to just iterate through it, which is linear, but I'll live, I guess. Yeah, I don't think there's really a fast way to do any of this. We're checking each leaf if we can merge. Yeah, I think it's kind of just doomed. Yeah, I'd rather have the logic out here than hide complexity, or hide runtime with a function call. Yeah, this might be inevitable. Something I was thinking about is maybe storing things with like multisets, but that seems... I like thought about it, but I don't think I need the faster lookup. I could be wrong about that, but not really sure. Okay. So the merge is what we care about now. I think what we could do is we could just do a swap. We could do a swap and then we can update the skip list. Okay, so let's, or I guess actually that means we could, yeah, instead of a vector with the leaves, it might actually make sense to actually use a multiset here. I might do that. Let's look this up actually, I'm curious. need to grow incrementally, but always be ready for immediate access. Okay. That could be interesting. I'm gonna use the bathroom real quick. And while I'm in the bathroom, I'll think about this. So yeah, I'll be right back. Don't burn the house down while I'm away. Cool. Alright, I'm back. Good bathroom break. Alright, I've decided we're gonna stick with a vector for now. Until we literally cannot work with a vector anymore. It could also be something that I just like benchmark, but I don't think I'll hit the point where like it matters meaningfully, so I think I'll just keep it as a vector regardless. Okay, so I think we just need to update. So we need to swap putters, or what's it called? Swap stored putters. Yeah. Yeah, so this doesn't exchange for all actually. New one remains the same. Okay, that would be a problem. Huh, okay. So that doesn't do what we want it to. Okay, that's actually very annoying. There's no good way to do this. I mean, we could just add another layer of indirection, which would be really funny, but I don't think that's what we want to do. Well, okay, I guess that is what we need to do. God damn it. Alright, we might need a shared pointer to a unique pointer. We might need to do that. That's quite annoying. So we're going to update child putter. We're going to update skip list, and then What is the other place we need to update it? We're going to remove from to-do or work list. So we want to remove that. Yeah, so so we so this updates the object, this updates the work list, and then we need to update all of the things that store info, I think. Yeah, so I just use the scroll wheel, sue me. I think we need to update uses then. Yeah, we can update this with the skip list, I think. Although this means we might have to use a multiset. This does not bring me joy. Maybe we could denest this one layer by turning this into like an actual function instead of doing it like this. And we can just give it the list. Right? That's the only state we keep, right? Or no, we keep the other list. We keep the uses list, and cur is the work list. How do we do this? So much state being stored. Okay. Yeah, I can't really think of a good way to do this actually. That's really annoying. We could just do a shared pointer to a unique pointer, and that would solve a lot of problems, but that also is just kind of gross, and I really don't like that. I guess we could also just do this, which is really funny. So we make shared here, we copy it. No, it's the same pointer. Oh, that's really annoying. How do we swap two objects from the pointer? Yeah, this is really annoying. Okay, we might have to do the second level of indirection here. Oh, weak pointer here actually makes a lot of sense, huh? Okay, well, I think we might need the indirection, or we need to redesign forest once again. I could either do that now or I could push it off to another stream. I'm gonna think about it a little bit more here. And if I don't really think of anything good, I think I will just push it off. We could leave this as shared pointer, and then we could use weak pointers elsewhere. All right. So non-owning. That could be useful for like the skip list itself, but I don't think that really gets us anywhere, to be honest. We might just have to do shared pointer to unique pointer. Yeah, okay, that's what we need to do. Alright. Okay. Let's... I guess we should just like... We could also just like make a swap function. Or like something that just like... Cause the register value is the same. We can just like... We can just get rid of the other tree, because all of our comparisons are with the leaf anyway, right? There's a lot of state that we need to update. Yeah, we'd be merging in things that we haven't traversed yet, so we don't need to modify uses at all. Or we might need to add things to uses, but we don't really need to modify a lot. Right? That makes sense. Yeah, that makes a lot of sense. Yeah, so we can update all of the leaves in uses. And then yeah, so we need, I guess we could, let's start writing this out. I don't want to do another layer of indirection because I think that would just be really, really slow. So, right, so we want to do this eventually. And we want update usage list. And these are kind of the local things, so we can do that and cur. So this one we want to add, I guess, like replace function. Or we want add virtual, I guess. Yeah, so we can do that. So that allows us to do the replace stuff. So that updates both of these, I think. Or no, it only updates the child pointer. And then we should do like, or actually, yeah, because we're updating the object, we don't need to do a lot of crazy stuff. And then, so we need to update the skip list first, I think. Yeah, and that's as simple as just removing the leaf and then adding the leaves, or where the leaf is being replaced into leaves. Yeah, we can do that. Maybe that could be like the other way around. That doesn't really matter. That's all semantics. Wait, so this is the skip list, and then update memory instruction. And we shouldn't need to update trees because it's already gone. So we just need to update leaves and memory instruction. Okay. Or propagate. Okay, well that kind of makes sense, I think. Yeah, I guess we could probably add the... We could probably do all this in one sitting. I don't really feel like doing it right now, though. Let's see if I have time. Okay, I think I have time. Let's implement some of this. I think we could, the least we could do is the virtual replace thing. What did I change here? Oh. To leaf to tree comparison correctly. Okay. So now we can work on this stuff. This should be pretty workable. Yeah, so we want a new virtual. This is this could also be a visitor. Actually, that might make sense. But then we need to write getters. That's really annoying. Yeah, let's make it a visitor. we hate everything, so let's make a visitor. I guess it kind of makes sense as a visitor anyway, so yeah. Or does it actually? Because we kind of just no, it does make sense. It does make sense. And then we just write getters for things, and like everything is fine. Alright, so let's steal that. Store it down here. Merge node or replace node visitor. I guess like I don't know, what do you even call this? I guess replace? It's not really replace. I guess like I don't know, cause it's like identity theft, you know, like it's like one node just literally copies the identity of the other and like makes the other node disappear, sort of. It's like what am I saying? Yeah, so that's kind of what we're trying to do here, I think. Just try installing Arch and messed up in a step. I think it's a little bit difficult, at least if Arch is the first distro you're installing. If you're dead set on Arch, I think Arch install is a really helpful tool. Oh, I can't type. Yeah, this thing. Wow, this is not very illustrative. But yeah, it gives you like a nice little installation screen, and I thought it was pretty good, at least. I didn't do it, but I've heard very good things about it. If you feel like, or like if you're not dead set on Arch, I think Fedora is more than sufficient. Yeah, the Fedora install process is pretty streamlined in comparison, so there's not really a wrong answer here, at least. Let's see what Reddit thinks. It's not official, but it exists on the wiki. Pretty reliable, yeah. Just like, if you're not doing like insane things with partitioning, is what people say, which makes sense. This is pretty funny. But yeah, that is, I guess, the advice I would give. Okay, so what am I calling this visitor? Some tile trees we have. Oh, we can just copy that. What about pop? I don't remember it having been maintained for a while. You'd have to double check that. But also it's like, it's also kind of just like why, you know? Like if you're gonna install Linux, like you may as well, I feel like you may as well go all the way at least. What do I even call this? Let's look up synonym of identity theft. I guess replace. I don't know. We'll just call it replace. Linux Mint is great to start. Yeah, that's like the generic go-to beginner distro. If you're not comfortable working with, I guess like Linux stuff yet, I think Mint is a good place to start. If you're comfortable enough with like Unix environments to kind of just like, I guess look things up, and if you're fine with like relearning how to walk, I think not even relearning how to walk, just like if you're fine with like the struggle and if you have the energy for it, I think you may as well start with Fedora. Identity theft node visitor, that would be crazy. I already have Forest. I think I've done enough with the insane names. I think I'll just do replace. IT node visitor. Actually, I guess maybe we could look at like the list library, if there's anything that we can like maybe take as inspiration here. I guess swap, not really. We could do like swap consume. Oh, duh, wait. This should just be merge, I guess. Yeah, we should just do merge node visitor. But then that looks like we're merging everything. But I guess merging node makes sense. Yeah, I guess this makes sense. I don't know, this is the most difficult part of any project, I swear. It's just naming things. You know, let's ask ChatGPT. Let's see what it cooks. If this doesn't cook, I will be annoyed. I have a visitor function that takes 2 tree nodes and turns the first one into the second one. What would a good visitor name be? Something node visitor. Entity theft node visitor. Oh, convert, yeah. Convert is a good one. It's not really. Chameleon. Shapeshift. Yeah, shapeshift is kind of the idea. It's not really replace. I like transform. Yeah, we're gonna do transform. Or no, that's not transform. We can do, I don't know. Actually, mimic makes a lot of sense, I think. Trying something like, the idea is like replacement, but also in a consumer way. Yeah, morph makes sense, I guess. transmute makes sense. Parasite. What code editor? I'm on Neovim. Well, this is ChatGPT, but soul transfer. This is too good. No, I don't really type fast. I'm just, I guess my raw words per minute is fast, but I'm very bad at typing accurately, at least. These are some pretty funny names. I might steal some of these. Parasite is really funny. Invasion of the Node Snatchers. Okay, who let ChatGPT cook? Why am I spending my time doing this? I could be working on an OS lab right now. We could do overwrite. Or yeah, I don't know. This this is so dumb. I should not be wasting my time staring at this page. We could just do convert, I guess. I guess like, yeah. What is Kimmy? Oh, I see. Yeah, nah, this is fine. I've found something that I'm happy enough with, so I don't really care. Okay, so this needs to go here. Actually, let's go here. Let's steal all of these. This should be convert node. Yeah, okay. Perfect substitution. Except for that one. That one's not a perfect substitution. Okay. So then we'll have to write getters and stuff, and that's really annoying, but all good. Actually, we don't even need a visitor for this. This is a little bit pointless. Why am I even making a visitor for this? What did I need it for? The replace function. What am I even replacing? If it's just a register, then like, what is the point of this? Yeah, this is a little bit pointless actually. We don't need a visitor at all. Yeah, we just need like a getter or something. We can just like throw this at the top, sort of like same reg. Yeah, I don't know. We'll do that next time. Let's do like, yeah, we don't need a virtual replace here. This is definitely overkill because the only thing we're merging is going to just be a register. So, yeah. Yeah, we shouldn't be messing with stores, so that should be fine. And then load is also like a barrier. Yeah, the only thing I see us actually like messing with is just what's it called? I just said the word. Just registers. We want to let's just update this. Instead of update child pointer, let's do, oh, what the hell? We want to identity theft the child should, or update the leaf putter through identity theft. we're just the direction's a little bit ambiguous how you think about it, because the leaf spot is being taken, but also like the leaf is becoming the other thing. So leaf and identity theft, leaf and tree to merge, or being merged. Okay, let's just do that. Okay. First try. Clone, it's not really like a clone though. It's because like it's also kind of a consume, I guess. I truly think identity theft is like the best way to think about it. For better or for worse. Yeah, I think this is a reasonable spot to call the stream today. I've got work to do. Thank you all so much for showing up today. I know the stream is at a bit of a weird time, but I need the work time for the OS lab, so I should probably get to that. If you're new here, make sure you like the stream and sub to my channel. It helps out a lot with the algorithm and gets my content out to more of you. And while you're down there, make sure you join the Discord. It's the best place to get pinged when I go live and chat with the broader community. Everyone's really chill, you should join. And of course, you should, if you haven't already, connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. Yeah, that's about it. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.